Hello everyone, welcome to CSE Core Concepts in my series of machine learning algorithms with implementation in RStudio. Now in this video, I am going to demonstrate the DBSCAN algorithm in RStudio. Now, if you have gone through my earlier videos on DBSCAN algorithm, you might remember that it is based on spatial clustering. Okay, it is based on the density. So here we require certain parameters and there are certain points within a stipulated distance which we called as an epsilon value. So we first give a measure of the distance and then based on that radius of that distance we determine whether a point is a core point. So core point means those points which satisfy the minimum number of points. So we want in a cluster. So if I am saying that I want at least 5 points in a cluster, so that is any point which is fulfilling that is a core point. Then we have border points and outlier points. So border point means they have one core point, but they do not have the minimum number of points to become a core point. So if you remember, we created such a matrix and we measured the small distance, and based on that we categorize the points as either noise, core or border points. Okay, and the number of core points were determining the number of clusters. So this is what we have gone through. So this is just a quick glimpse of that algorithm. For the detailed version of the algorithm, I suggest you to please go through my earlier video on the DBSCAN algorithm. So let us implement this, get started with the implementation by including some of the library files. So one of the library we are going to use here is FPC. I will tell you what is it used for. Then a library, of course, DBSCAN we require to perform the DBSCAN algorithm, and we will require some other tools, some other libraries like DevTools and FactoExtra to perform some of the functions. Okay, so these are the 4 library files which we are going to require. Now FPC and DBSCAN both have that DBSCAN function, right? So I will show you using both, right? Now the data set using which I am going to perform this demonstration is using the IRIS data set. Now IRIS data set is something which is already there in the RStudio, so we did not import it. So it is already there, but if you do not have that or you want to import it, you can also import it, right? So let us have a look at our IRIS data set. Now let us have a look at this data set. Now here, so flowers are differentiated. Iris, there are 3 varieties of iris flower. They are differentiated based on the sepal length, sepal width, petal length and petal width. Okay, so these 4 are the parameters for differentiating them from one another. Now in the file it is actually the thing is that the one which is inbuilt, they are already divided into classes. So if you do not want the last one, you can always remove the class. Okay, that is okay. So class can also be here. Okay, that's fine. Since in this data set I have cleaned it and the classes are not being shown. So because IRIS data set can be used for the classification problem also to classify the data. Let's say for example, let's import the file. Okay, so iris.csv. So we will have a quick look at the data file. So this is there are 150 observations of 4 variables. So let us see the structure of the iris data. So there are 4 variables of now sepal length, sepal width, petal length and petal width or in centimeter, and all of them are numeric, right? Now we have to have the parameter, that is the EPS parameter, right? That is the radius value. Obtain the EPS value. That is the maximum distance. We want to find out the maximum distance. That will be the maximum radius. So we can perform numeric vector with the distance to find its k nearest neighbors, right? So EPS, if you are keeping too small, okay, if you are keeping the radius too small, then your clusters will be sparse. Sparse means what? Not dense clusters. They will be very, very far and small clusters and will be defined and as noise, and if it is too big, then you have a dense, very dense cluster. Okay, too many clusters will form. So you have to choose the value that way. So in that case, we can use distance plot. We can find out is equals to KNN. KNN, you remember, K nearest neighbor. So KNN will find out using the KNN distant plot function. We are going to pass the iris data with K is equals to 3. Let's say, okay. So let's see the distance plot. Yeah, we can see here the distance plot. See, this is how it is being sorted by the distances. Right? Okay. So let us now say our EPS is, let us see a minute. Yeah, so you can see the distance varies. So we cannot take very less distance, like less than 0.2. Also we cannot have very high distance also, like more than 0.8. We can take a mediocre distance, that is, let's say between 0.4 to 0.6 we can consider as 0.45, right? Okay, we can take certain distance like that. So let's say EPS is equals to our 0.45. This is just for our noting. Okay. So if I say abline, if I am going to abline on that, so H is equals to 0.4, and let's see. Yeah. So if you see here, the line has been drawn. This is what is there, 0.4. Okay. So you can see here that two breaks are being done, neither too small, neither too less. Okay. Fine. So let us do the density based clustering. Now I told you to do the density based clustering, you require the DBSCAN function. Now DBSCAN function is also available in FPC package also, and also in DBSCAN package. So I will show you both of them. Okay. So let us say we are using the FPC package first. So FPC underscore iris. So let's say FPC, how you call it, we are going to write FPC and with two columns, and DBSCAN is the function. So the data I am going to pass is the iris data, where my EPS value I have to pass it, because otherwise it cannot form the cluster, and the minimum number of points which I require, let's say 4. At least I require 4 points in a cluster, right? And to see, let's say FPC underscore iris. So let's see this one and this one. So you can see if I am using this, there are 150 points. So there are 4 clusters, sorry, you have this 1, 2 and 3. Okay, so now border, how many borders are there? Borders are 17 borders, seed is 0 and total 17. Then 3, 45, 48, 10, 71, 81. Okay, so points which could not belong to any cluster. Now you will be wondering, when I have given k is equals to 3, then what is this 0 doing, right? So actually 1, 2 and 3 are the 3 clusters. Okay, this 0 is the noise. Points which are not belonging to any cluster are the noisy points, right? So there are 70 noisy points. Now in the first cluster, there are 3 border points, 45 seed points. So total there are 48 points in the first cluster. In the second cluster, 10 are border points, then 71 are 71 are the seed points, and total is 81. And for the cluster number 3, there are 3 border points, 1 seed points and 4 total points. Okay, so this is how it is being formed. So 17 points are noisy points, what we can see over here. Now the same DBSCAN we can perform using the DBSCAN function also. So DB underscore iris is equals to DBSCAN. This is the package, and in that package we have the function DBSCAN package, that is iris data. EPS is equals to 0.45, and minimum number of points is equals to 4. That same criteria we are keeping here also. So DB underscore iris, right? So let's see. Yeah, so you can see here again the way it is little bit written different. That's the only change. So 17 same we are getting. 17 are the noisy points. It will give results same. Okay, that does not make any difference which package you are using. That won't make any difference. So here 81 belongs to your second cluster and 4 belong to your third cluster. That's fine. Now let us see the visualization. Let us perform some visualization using the, so for visualization we have used this package facto extra package. Okay, so let's say fviz is equals to cluster, sorry, fviz cluster, sorry, yeah, cluster. So if you want to do that fpc using that first one, let us see the iris data, okay, and geom is equals to point. So you can see these are the 3 clusters which are being formed. The second cluster was having the highest number of points, that is 81. So this red one is the first cluster having 48 points. This green is the second cluster and this one is the third cluster having only 4 points. These all small dots are your noise. Okay, you can see here. So similarly, you can do the visualization using this DBSCAN package also. DB package also, that does not make any difference. So DB iris, data and geom is equals to point. DB iris, sorry, I have written a wrong function name, fviz cluster. Yeah, so you can see similar one you are going to get, right? So you can even try here. I have given minimum number of points is equals to 4. You can of course try making clusters with minimum by changing the minimum number of points. Let's say if I want the minimum number of points as uh, let's say for example 3, that also you can do. So you can always change the minimum number of points here. So instead of writing, let me change it here itself. So let's say you can have minimum number of points 3. So you can see the cluster. Okay, so the number of noise has reduced when you are decreasing the minimum number of clusters, right? So 0 1 2 3 and 4 clusters are being formed when you are saying in this algorithm, right? So yeah, so you can see here. So here you can say minimum number of points you can even increase. Let's say the 10th one. Okay, so it was giving 10. Here you can see. So still, even if you are giving 10 points, not more than maximum 4 clusters are formed, right? So earlier, let's say when you are creating the k nearest distance, keeping only 3 neighbors in mind. Okay, so if when we were doing it with minimum number of points, let's say 4 initially, right? So you thought that what is the 0th cluster doing? So there were only 3 clusters which were being formed, right? So now if you are saying here it is 3. So with 3, again 4 clusters are being formed. So even if I am increasing the minimum number of points to 10, not more than 4 clusters I am getting. That is the maximum number of clusters which I can get. Okay. So this is the implementation of the DBSCAN algorithm and how you can select the proper epsilon value. You cannot take too less value or you cannot take the too high value. So this is what we have seen by plotting the distance. Okay, so we have seen by plotting and we have seen that how does we can calculate points sorted by the distance values. So I hope you understood this video as how to implement. So if you have want a clear understanding actually how the DBSCAN is working, so you can always go through my theoretical videos. Fine. So don't forget to like, share and subscribe to CSE Core Concepts. Thank you.